Okay, so now for the read and got it's. And I'm going to tell you right now, if you're just watching the got it's, that's not a good idea. You need to be working them. You need to watch the problem one example, then try to work both of the got it's. Then watch the video. Don't just sit back and watch it, because there's no way you're going to get this method if you just try to kind of halfway get through it. So there you go. All right, so let's take a look at this one. Solving a system by adding equations. Now, like we talked about just a moment ago in the vocab, what we're looking for is something that eliminates here. Notice I have opposites, plus 5y minus 5y. And I line them up just like that. And I go ahead and I add. So 2x plus 6x is 8x. 5y plus negative 5y is 0. 17 plus negative 9 is 8. Divide off that 8, and x is 1. Then we have to use substitution, so take that x is 1, plug it into either of the other two equations, run it through, and find that y is 3. So here's your A, and again, don't just watch the video, I need you to go back and actually work it. So we've already lined them up here, and this is a standard form. It usually works best that way. And we should notice right here, these are opposites. So I'm just going to go ahead and add. 5x plus 3x is 8x. These guys create 0, so 0y. And then I get equals, so negative 32 plus 48 is 16. Then we go and we divide off that 8. Divide off the 8, and x equals 2. So there's the first part of it. Then I'm going to take my 2 and plug it into either one of the other two equations. It doesn't matter. So I'm going to take the second one. 3 times 2 plus 6y equals 48. 6 plus 6y equals 48. Subtract my 6. 6y equals 42. Divide my 6. And y equals 7. So my point becomes the point 27 is my solution for this system of equations. Now again, you could graph them, right? You could try, the substitution method, but this is another tool for you. The quiz and test tries to tell you, hey, use this specific method, yet you pick the one that you like the best now, and which one works best in certain events. Graphing them, some of them might be kind of tough if they're really high numbers, right? Or if they're fractions or things like that. So we have here again, line them up in standard form, and notice right here, these two eliminate each other. So I've got 3x and negative 3x, and I get 0. Let's see, negative 3y plus 4y, negative 4y is negative 7y. Don't lose those negative. Equals 14. Divide off the negative 7, and y equals negative 2. Now, again, take that and plug it back into either of the other two. It doesn't matter. You're going to get the same answer. So we've got, I'm going to switch colors here. So we've got negative 3x minus 3 times negative 2. There we go. Equals 9. Negative 3x plus 6 equals 9. Subtract 6. Negative 3x equals, 3, there we go. Divide, it's an x, divide the negative 3, and x is negative 1. So my point becomes negative 1, negative 2. This is the solution for this set of equations. Now you can also solve by subtraction. So something very similar here. We notice that we have, so we have to first write them. The theater club sells a total of 101 tickets to its first play. A student ticket costs $1. Adult ticket is $2.50. Total ticket sales are $164. So A is the number of adult tickets. S is the number of student tickets. So we're doing two systems of multiple equations or multiple variables here. So again, we have that total equation first. A plus S is 101. And then we have the mixture equation. 250 for the adult, 1, should be a 1 right there, right? For the student is 164, that's the total dollars. This gives us a system. Now notice here, both of these, right? Both of these have a positive S. If you add that, you're going to get 2S. But if I technically subtract, so if I write in a subtraction sign here, right? So A minus 2.5A is negative 1.5A. S minus S is 0. And 101 minus 164 is negative 63. Divide off that 1.5, and A is 42. Then, again, pick either one, plug in the 42, and we find that S is 59. So student 59 tickets, adults 42 tickets, and don't forget to label that. Alrighty, so here we've got washing 2 cars and 3 trucks takes 130 minutes. Washing 2 cars and 5 trucks takes 190 minutes. How long does it take to wash each type of vehicle? So we're going to need some let statements here. Let, right, T equal minutes to wash a truck, right? It's okay, there we go. And C equal minutes for a car. So I do know that if I have 2 cars, right, 2 times the number of minutes for a car, plus 3 times the minutes for a truck, that's 130 minutes. I also know if I have 2 cars and 5 trucks, that's 190 minutes. Now notice here, by subtraction, I'll be able to eliminate the C's. So 2C minus 2C is 0. 3T minus 5T is negative 2T. And 130 minus 190 is negative 60. Divide off that negative 2, and T is 30 minutes. Now I can take and substitute my 30 back into one of the 2 original equations. So we'll say 2C plus 3 times our 30 for the truck equals 130. 2C plus 60 equals 130. Subtract our 60. 2C equals 40. Divide off our 2, and C is 20 minutes for a car. So there we go. Okay, so far we've been, you can call it lucky, right? The variables match up, so you can eliminate one pretty easily. But that's not going to always be the case. If we take a look at this example up here, none of them match up. There's no 2 and negative 2 or 15 and negative 15 or something like that. But I do notice that here, if I multiply the bottom equation by negative 3 all the way through, I would end up with a negative 15 here and a positive 15 here. So, if I were to do that, come down here, so follow me down here, we're going to carry across that top one, negative 2x plus 15y equals negative 13. Multiply the second equation by 3. So 7 times 3 is 21. Negative 5 times 3 is negative 15. 17 times 3 is 51. Now I have a 15 and a negative 15. So we say negative 2x plus 21x is 19x. The y's are eliminated, right? Negative 32 plus 51 is 19. Divide off that 19, x is 1. Now again, substitution, x is 1. Substitute in either one, it doesn't matter. And we find that y is negative 2. So our solution for these 2 equations, if I were to graph them, they would intersect at 1, negative 2. Okay, on this next one, we're going to notice here, there's a couple different options, right? But we're going to notice here that that I can multiply. So again, we notice that these 2 right here, if I multiply the top one by 3, I get negative 6 and positive 6 for my elimination. So we're going to do that. We're going to run we're going to multiply a 3, or run a 3 through the top one. So this equation becomes negative 15x minus 6y equals 12. And the bottom one doesn't change. That is still 3x plus 6y equals 6. Now we're going to go through and add. If anybody will tell, I like to add these as opposed to subtracting. So anyway, on the top, we're going to get negative 12. Whoops, that didn't quite work out the way I thought it would. There we go. Negative 12x, the y's are gone, equals 18. Divide off the negative 12, and x is negative 3/2 once you reduce it. I know, right? Fun. So let me get this out of the way, and we are going to use substitution to solve for the other one. So we go back and we plug, so we take the 3, I'm just going to take this one, doesn't matter which one you really pick. Plug in our negative 3 halves, plus 6y equals 6. So I get negative 9 halves plus 6y equals 6. There we go. And I add 9 halves to both sides, and we get 6y equals 21 halves. Right, so add that 9 halves to both sides. Multiply off our 6 with the reciprocal of 1/6, and we find that y is, once we reduce, 7/4. Now this one's kind of ugly, but it doesn't matter. That is the answer. So we get negative 3 halves, 7/4 for our answer. Or if you prefer the decimal equivalent, down here, negative 1.5 and 1.75. So again, they can have fractions, but the system still works. This would be one that would be impossible to graph to solve, by hand anyway. Okay, so sometimes neither of them lines up. I don't care what I multiply by. I can't just multiply one equation like this. There's nothing I can find that would turn any of these, like 3 into 4 or 2 into 3 or the reverse. So you can multiply both. And you notice here, if I multiply the top one by a 3, and the bottom one by a 2, I would get 6's on both, and I'd be allowed to subtract. So let's explore that here real quick. So again, if I multiply the top equation by 3, I'm going to get 9x plus 6y equals 3. The bottom equation by 2, 8x plus 6y equals negative 4. Now I can go ahead and subtract, and I can wipe out. Now you could also have multiplied by a negative, and just add it. So I could have made this negative 8x minus 6y equals positive 4. And sometimes I like to do that. You could have also taken the top equation and multiplied by 4, and the bottom one by negative 3, and eliminated the x's instead. Either way, lots of ways to do this, to catch, to be able to eliminate. Alrighty, next one we're going to have the exact same, you're going to use this method on the next slide. Okay, so on this next one, I'm going to notice right off the bat that I'm going to have to multiply both equations by different numbers to be able to eliminate. And then what I've decided to do is, right here, I'm going to do a 2 on the top and a 3 on the bottom, creating positive 6y on the top and negative 6y on the bottom. So I'm going to be able to add and eliminate the y's. So let's do that real quick here. So again, the top one we're going to multiply by 2, the bottom one by 3. So when I do that, I get on the top 8x plus 6y equals negative 38. And the bottom, I get 9x minus 6y equals negative 30. Now I'm able to add, and again we're going to eliminate those y's. So I get 17x equals negative 68. That's an 8, there we go. Divide off the 17. And x equals a negative 4. Look at how nice that came out. Then I'm going to plug that negative 4 into one of the two equations. So we're going to get 4 times negative 4 plus 3y equals negative 19. Negative 16 plus 3y equals negative 19. Add that 16 to both sides, and 3y equals negative 3. Divide off our 3, and y equals negative 1. So I get the point 4, negative 1. So we can also use the, or sometimes we get those special cases where we get infinitely many solutions, right? Or we get no solutions. And the answers look the same as they did when we started this whole journey. So if we take a look here, if I eliminate, obviously nothing lines up here, but I can multiply the bottom one by negative 2. So this becomes negative 2x minus 6y equals negative 18. When I do that, everything subtracts. Boom, 0 equals 0, right? Get those identities. When we get the identities like that, it means we have infinitely many solutions. In other words, it's the same line. It doesn't matter what you decide to do. If you multiply the top by 2, you're going to get the same thing. 0 equals 0, right? Or if you get 5 equals 5, whatever you get. But again, it'll be 0 equals 0, those identities on this kind. Now, if you had gotten something else that didn't make sense, like 0 equals negative 5, then that means there's no solution, that the lines are parallel. So here we have these two, and if you notice, by the way, if if you happen to notice. These are really, notice that these are in standard form, and that the negative 2x plus 5y is the same in both, but they have different constants on the other side. That means those are parallel lines, which means that there's no solution, right? But if you didn't notice that, let's say you decide to go ahead and add or subtract, try to subtract these two. So we're going to end up subtracting, right? So I get negative 2x minus a negative 2x is 0, 5y minus 5y is 0, and 7 minus 12 is negative 5. Well, since 0 does not equal negative 5, we know these lines are parallel, and there is no solution. So look for those special cases again.